So for part 2 of this test, we're dealing with the Roman numerals and the bases. And on my sheet of the front of this test, I'm going to give you all the Roman numerals that you need. The first few problems ask us to convert from Roman numeral, or to write something as a Roman numeral. And that's probably the harder part. In order to do this, that's actually the easier part, isn't it? In order to do this, I'm going to take any number that's given and I'm going to break it up into its hundreds part, its tens part, and its ones part, or thousands if it had thousands. And then I'm just going to go through and figure out what each value is from the table that's going to be given to you on the test that you don't have to have memorized. So the 400 part of this is a CD. The 90 part of this is an XC. And the 1 part of this is an I. So the answer to problem 15, the Roman numeral for 491 is going to be CD, XC, I. And that's all there is to do for that. That's a friendly problem. I'm going to do the same thing for number 2. So I'm going to rewrite this in its thousands, because there's 1,000, its hundreds, its 50s, its tens, which is 50s, and its ones. So now I go for each one of these. 1,000 is an M. 400 is a CD. 50 is an L, and 2 is a double I. The answer to problem 16, the Roman numeral representation for 1,452 is M, C, D, L, I. Last easy one, then we'll do the backwards ones. 953 is 900 plus 50 plus 3. 900 is CM. 50 is L, and 3 is III. 953 as a Roman numeral is going to be CML I. And I'm checking my answers to make sure I'm not writing anything silly down as I'm doing these, which you should always be doing too. The next direction really is the more work one. And so in order to deal with the Roman numeral MCMXLVII, I'm going to, from my sheet of Roman numerals, pluck out all the ones that we need here. We need that the I is equal to 1, V is equal to 5, X is equal to 10. I'm just stealing from this chart. Actually, I stole it from here earlier and I messed up and redoing this. L is equal to 50. C is equal to 100. D is equal to 500. M is equal to 1,000. Those are the 7 basic Roman numerals. And then from this chart, I need anything that's representative of a 4 or a 9. IV is equal to 4. And, can't see it as you can, IX is equal to 9. XL is equal to 40. XC is equal to 90. CD is equal to 400. And CM is equal to 900. So when I go to write down this number, MCM, when I go to do 18, which is taking M, C, M, X, L, V, I look at this column first. First I see, is there an I preceded a V? That's a VI, not an IV. I don't have one of those. Is there an I before an X? Well, there's the only X. There's no I before it. Is there an X before an L? Yes. So I need to keep those together. Is there an X before a C? That C is the only C. There's no X before it. Is there a C before a D? No, there's no D. Is there a C before an M? Yes. So now I'm going to find values for everything that I have highlighted or unhighlighted. I'm going to find a value for the M, the CM, the XL, the V, the I, and the I. M is equal to 1,000. CM is equal to 900. XL is equal to 40. V is equal to 5. And each of the I's are equal to 1. And now I'm going to add up these numbers. So 1,000 plus 900 plus 40 plus 5 plus 1 plus 1. I think that's 1947. But my calculator won't let me down if I don't mess it up. 1,000 plus 900 plus 40 plus 5 plus 1 plus 1. The answer to problem 18, the Roman numeral that's given, is equal to 1947. For number 19, I'm going to use the same... Oh, I'm getting a mess here. Let me try to get organized real quickly. Number 19 wants me to take the Roman numeral CDLXXIV and write it as a Roman numeral. And so immediately I go to my list and I look for my 4s and my 9s. I ask myself, is there an I before a V? Yes, I'm going to keep those together. Is there an I before an X? Well, there's 2 X's, but there's no I's before them, so I'm not worried about it. Is there an X before an L? Well, there's an L, there's no X before it. I don't need to worry about it. Is there an X before a C? There's a C, there's no X before it, so I'm not worried about that. Is there a C before a D? Yes, there is. I need to keep those together. There's no M, so that's everything I need to contend with. And now I'm going to find values for each one of these. So I'm going to find a value for a CD, an L, an X, and an IV, all on this sheet now. CD is equal to 400. L is equal to 50. X is equal to 10. X is equal to 10. IV is equal to 4. I'm going to add these up. 400 plus 50 is 450. Plus 10, plus 10, plus 4. I think that adds up to 474. I don't think I need my calculator to do that. My answer for number 19, the Roman numeral that's given, is equal to 474. Problem 20 wants me to take the Roman numeral L, X, 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 IV, write it as a regular Hindu Arabic number. I look to see if there's an I before a V. There is, so I keep those together. There's not an I before an X. There's an LX, but not an X before an L. There's no C's, there's no D's, there's no M. So those are the only things I need to keep joined. And then I'm going to find a value for L, X, 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 and IV. L is equal to 50. Each of the X's is equal to 10. And the IV is equal to 4. And I just need to add these up. And I don't need my calculator to know that that's 84. But I could go 50 plus 10 plus 10 plus 10 plus 4. And get my answer of 84 for problem 20. So as a Roman numeral, problem 20 is equal to 84. 21 wants me to convert L, X, 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 IV. Boy, it feels like the same. This is exactly the same problem. Whoa, hold on. That was problem 20. Take that back. Problem 21 is not that. I had some stuff written on my sheet that I didn't like, so I was hiding that from you because I taught it a little bit differently this time. Now we're into bases. So I'm done with Roman numeral part of the review, onto the base part of the review. To do this version, to convert from a base into base 10, that's the easier way. That's just writing the number backwards and then multiplying by the powers of 5. So for problems 21, to write 214 base 5 as base 10, I'm going to write the number backwards. So I wrote 412, which is just writing the number backwards. And then next to each of the numbers, I multiply by 5 with an exponent. The first 5 I get an exponent of 1, and then I add 1 to the exponents. So I took the 4, the 1, and the 2, wrote it backwards, multiplied each by 5 because the base was 5. I start with an exponent of 0, and for each successive 5, I increment up by 1. And now I'm going to multiply. It's all something I can do in my calculator now. This is 4 times 5 to the 0, plus 1 times 5 to the 1, plus 2 times 5 squared, or 5 to the second power. 214 base 5 is equal to 59 base 10, and that's going to be the whole answer for 21. 22 wants me to take 103 base 4 and change it to base 10. I'm going to write the number backwards. I'm going to write a 3, a 0, and a 1. I'm going to multiply each by a 4. I'm going to give each of the 4s an exponent, starting at 0 and going up by 1 each time. And then I put plus signs between. So 103 base 4 can be turned into base 10 by doing this operation, which is 3 times 4 to the 0, plus 0 times 4 to the 1, plus 1 times 4 to the 2. The answer to problem 22, 103 base 4, is equal to 19. Last one of going the easy way, to change 54 base 6 into base 10, I write the number backwards, so I write it as 45. I multiply by 6 to the 0. I multiply by 6 to the 1. I put a plus sign between. Break out my calculator. 4 times 6 to the 0 plus 5 times 6 to the 1. And I get, for an answer, 34. The last 3 problems on the review are going the harder way, which isn't that hard. We're given a number in base 10, and we're asked to convert to another base that isn't base 10. It's probably a glitch here in the video. These few problems are from the end of 2.6, where I started teaching it a different way than I initially taught it, so I'm just fixing this video. So problem 24 wants me to take 122 base 10 and convert it to base 5. And in order to convert something into base 5, I need to know all the powers of 5 that are less than that number. And once I get to a power of 5 that's bigger than the number I'm changing out of, then I can not worry about that number and start my work. So 5 to the 0 power is the first power of 5 that I need to worry about. It's 1, it's less than 122. I'll move on to the 5 to the first power. 5 to the first power is 5. It's less than 122, so I'm going to check 5 squared. 5 squared is 25. It's less than 122, so I need to keep going. Now I'm going to 5 cubed, and 5 cubed is 125. It's too big. I'm not going to worry about it. So I need all the powers of 5 that are less than or equal to 122, and now I'm going to do 3 divisions. I'm going to divide with a 25 in front of my division bar, or outside my division bar, a 5 and a 1 outside my division bar. I'm going to take the 122 that I'm given, and now I'm going to divide. Too many glare. I'm going to divide 122, divide it by 25, take the non-decimal part, which is a 4, multiply the 4 that I put on top of the division bar by the 25 outside the division bar, which is 100, and subtract 122 minus 100 is 22. Take my remainder over to the division bar next to it, as long as this number is bigger than or equal to that number outside the division bar. So I took my 22, put it under the next division bar. Now I'm going to divide 22 divided by 5. I get 4 point something. I put a 4 on top of my division bar. I'm going to multiply 4 times 5 and get 20. And now I'm going to subtract 22 minus 20 and get a 2. Take my remainder. Now I'm going to go 2 divided by 1 and get 2 for on top of my division bar. Then 2 times 1 is 2. Subtract. Once I get a remainder of 0, I'm done doing the division. If there were more division signs after this 0, I'd start putting zeros on top of them, but there isn't. I'm ready to write my answer. My answer is going to be 442 base 5. 25 is a similar problem. It wants me to change from base 10 to base 4, so I need all my powers of 4 that are less than or equal to 214. And I know what they are. 4 to the 0 power is 1. 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. And 4 to the 4th is going to be too big. So I need all the powers of 4 that are less than or equal to 214. I stop once I get to one that's too big. And now I'm going to make up my divisions with a 64 in front of my division bar, a 16 in front of my division bar, a 4 in front of my division bar, and a 1 in front of my division bar. Take this starting number 214, sneak it under a division bar, the first one, and do 214 divided by 64. Gives me 3 point something, so I put the 3 on top of my division bar. This glare drives me crazy. And I'm going to multiply this 3 by that 64 and get 192. I'm going to subtract 214 minus 192 and get 22. Carry my remainder over to the next division bar unless it was less than 16. If my remainder was like 7, I would skip this one, put a 0 on top. But since 22 is bigger than 16, I can put it on top under the division bar, and then divide 22 divided by 16. I get 1 point something. I put a 1 on top. Go 1 times 16, which is 16. And then subtract 22 minus 16 and get 6. If my remainder was less than 4, I'd skip this 4 and put a 0 up there. But since 6 is bigger than or equal to 4, I put it on top under the bar. And now I'm going to go 6 divided by 4, which is 1 point something. I put the 1 on top. Now I'm going to go 1 times 4 and get a 4. And then 6 minus 4 is 2. Carry my remainder over. Now I'm going to go 2 divided by 1 is 2. 2 times 1 is 2. And then subtract. My answer is going to be 3, 1, 1, 2, base 4. Base 2, you often get zeros, and that's a good base. So to convert 15 to base 2, I need all the powers of 2 that are less than 15. And I'm just going to write them down without using my calculator because I know these really well. Notice I'm writing them backwards because I need the biggest power to be first, the smallest power to be last. So the powers of 2 that I need to concern myself with are 2 to the 0, which is 1, 2 to the first, which is 2, 2 squared, which is 4, 2 cubed, which is 8. I don't need 2 to the fourth, which is 16. So I'm going to do my 4 divisions. I have an 8 out front, a 4 out front, a 2 out front, and a 1 out front. For the first one, I'm going to put a 15 under my division bar. I'm going to do 15 divided by 8, or 8 goes into 15 one time. I'm going to go 1 times 8 is 8. Subtract and get 15 minus 8 is 7. Carry my remainder over. I'm cheating and not using my calculator. 4 goes into 7 one time. 1 times 4 is 4. 7 minus 4 is 3. Carry my remainder over. 2 goes into 3 one time, or 3 divided by 2 is 1 point something. You put a 1 out front. 1 times 2 is 2. Subtract the 2, get a remainder of 1. Bring my 1 over. 1 goes into 1 one time. This is going to be 1, 1, 1, 1, base 2. Let me make up an extra problem. I want something with a 0 because sometimes on the test I get a 0. And I bet you if I change, how about 31 to base 3. I think that's going to have some zeros in the computation. I want to make sure to do one with a 0 in the computation. So how would I change 31 to base 3? Well, I'd write all the powers of 3 that are less than or equal to 31. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81, which is too big. So to convert 31 to base 3, just because I want you to have an example that has a 0, I'm going to put a 27, a 9, a 3, and a 1 in front of my division bar. First, when I put a 31 outside my division, under my division bar, I go 27 goes into 31 one time. Then 1 times 27 is 27. I'm skipping my calculator because for me it's quicker to do it without my calculator. Now 31 minus 27 is 4. I'd like to put the 4 under this, but 4 is smaller than 9. And anytime your remainder is smaller than the number outside the division bar, you skip that one and put a 0 on top of it, move on to the next one. Now I'm going to say 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. Bring my remainder over. 1 goes into 1 one times. 1 times 1 is 1. 1 minus 1 is 0. If I was asked to convert 31 to base 3, it would be 1011 base 3. I just sometimes accidentally, when I make the test, there's a 0 that comes up, or sometimes 2-0 that comes up when you're asked to change into another base. So I just wanted to sneak that in there. Even though it wasn't on the practice test, it is definitely something that could make its way onto the test. Last problem on this review doesn't really even belong in this group, but it's on the test, and I asked this question on the test consistently, and it wasn't on the first half of the review, so I just threw it on as a last problem here, just to make sure you're prepared for this. So 27 said a car is traveling at a speed of 40 miles per hour. What's its speed in kilometers per hour? Because the per hour parts are the same, I really just need to change from 40 miles to kilometers. And the per hour part is going to remain because that's a consistent. So I'm just going to do this. I'm going to start with 40 miles, and I'm going to change it to kilometers by multiplying by a fraction that has what I want to change into in the numerator. I want to change into kilometers, and what I want to get out of in the denominator, I want to get out of miles. I snuck this from my table because I knew I was going to need it. I'm going to put a 1.6 next to the kilometers, a 1 next to the miles. The miles will cancel the numbers in the numerator, so I'm multiplying. When I multiply 40 times 1.6, I get 64. So the numerical part, 40 miles, is the same as 64 kilometers. But this problem's asking about what's my speed in kilometers per hour. I ignored the per hour part, but I can sneak it on here for my answer. In my answer, I can write an abbreviation for kilometers per hour for the speed. I think that's the appropriate abbreviation. Or I could say 64 kilometers per hour and write it in words. Either would be an acceptable answer. But this problem's always on the test, and so I just wanted to make sure that you had it in your notes as you're studying for the test. So that's the end for our practice test. If you can do all the problems on any of my practice tests, you should be able to do every problem on a test. I never ever intentionally put a problem on a test that isn't just like something on a practice test.